a lot of companies, but the LC problem, it is very important problem. No matter what, if you watch this or not, do watch this problem. Coming on back, it simply says that you are given the root of a binary tree. As always, we are given the root of the binary tree with n nodes. Okay, I have n nodes. Each node is ununiquely assigned to a value. Okay, we have value 1 to n assigned to that, and I'm also given the integer start value representing the value of the start node s, and a different integer value which is destination value, which is, let's say, d. So as you can see in this diagram, I have some start value, I have some destination value. Same way representing a node P and Q as we did in a problem LCA1. Now why I'm referring LCA again and again? Because it has to go and find the shortest path starting from the node S, which is a start, ending at the node T, which is the next node. Generate the step-by-step directions of such pattern as a string consisting of only the uppercase letters. For each letter indicates the specific direction. Shortest path. You have to go and try for the shortest path. So if you have any tree like this, this node is S, this node is T, or let's say this node is P, this node is Q. You have to go from node P to node Q. So you will have to go up to some parent, then go down to your node. Now, what is the parent which has linkage to both the nodes, and that parent is the lowest parent possible for me? That is also called as LCA, least parent, which is least ancestor, which is common between both the nodes P and Q. So I will start from P, I will go to my LCA, and then I will go directly to my Q. There could have been other possibility of going up, going up to root, then coming down back. So you see that this extra edge will add extra 2 steps, which I don't require. So it is not at all a good thing to go above my LCA. This is why I will go from my node P to my LCA, then I will go from my LCA back to my node Q. And this is what the problem asks us you to do. So from your node P to your LCA, as you know that for sure node P will be down, LCA will be up. So you will be going up, only up you will go. So all the steps, you can just count the number of steps, or you can just take all these steps whatever you want. Just modify that steps to up. You will only go up from your node P to your LCA. But from your LCA to node Q, it's a simple DFS traversal, which is simply going down, making sure if you are traversing to the right side, put in your string again, because you have to generate the path. So you have to put R as you move right. If you move left, you put as L. So in this scenario, if I would have showed you that if, let's say, I want to generate the path to reach this string, or basically this node P and this node Q. So again, forget about the LCA. Forget about, like, let's say you're starting from this root node. Imagine about that part. So if I would have asked you, start your traversal and give me the path from root node to this node P, you will have tried what? Simple recursion. That's what you try, simple DFS. But in this simple DFS, you have, as you go to the left, you will put L. Go to the left, put L. Go to the left, put L. So for this, the path I will say will be LLL, which I have built so far. Now, one way could have been that you store L here, here is LL, here is LLL. Either you store this L at all the levels, but that will incur extra memory, which I don't want. So I will just keep one string, which is the path string, and I'm modifying that string only. But Aryan, as you will go on back, yeah, as I go on back, I will remove the extra L. Then I go on right, so I'll add an extra R. So here it will be LLR. Again, as I go back, I will remove R also. Then I go back, I remove L also. Then I go right, I will add a R. Then I go left, I will add a L. So for this, the string will be LRL. This, as you go back, you remove something that is called as backtracking. If you don't know, please go and watch this video. I give a quick recap. So now you know that you will use this approach to find the LCA of two given nodes. When you have found the LCA of two given nodes, you will start your simple recursion with backtracking traversal to achieve your path for the node P, path for the node Q. When you have achieved these two paths, you know that this is the path, sorry, yeah, this is right now from the root node, which I have right now made. But now you know that you will start your DFS traversal, which is recursion, from your LCA. So it will be your L and then R. So this will be up from LCA to node P, it will be LR. Same way, it will be R and then L. So it will be RL. Now you know that LCA to node P, it is RL. LCA to node Q, it is LR, it is RL. And you know that you have technically moved from P to LCA, which means from bottom to top. So no matter what all values are you are having, replace all of them with U. So from P to your LCA, you will use UU, and then from LCA to your actual node Q, you will use RL. So this is your final answer. Cool. Let's combine everything together and let's see the code. This is the exact same code as we saw in the LCA problem explanation in this video. Now, the only change is I will firstly get my LCA node by calling this function. The only change from that code to this code is now I'm comparing the values itself, and that I taught in the above video also. You might be asked to compare values, strings, anything. Just compare with the earlier in the LC problem. I was comparing with the node, actual node itself. But now I'm comparing a value. That's completely fine. Now when I have grabbed the LCA node, my task was to grab the strings. So I made LCA to start string, LCA to end string. This will get me the string from LCA to the start node, from LCA to the end node, which is node P and Q in our cases. So I will call my simple DFS traversal starting from my LCA node. Currently my string is empty. I have passed in the P and node Q, which is the start node and the end node. Now I will simply go and ask my simple recursion, simple DFS call. This is my simple base case. This is the simple going on to the recursive case, which means calling the DFS for left, calling the DFS for right. The only change is as you call left, make sure to put the L in your string, but you know that you cannot make copies. So you have passed this thing by address. Thus, you will have to use your backtracking mind in this. So you will, before moving forward, you will pop it back, right? Again, this is a simple backtracking concept, which I expect you know. If not, just go and watch one crash course, you will get it. Then same way, I will go to R and then pop back R. Now coming on to the base case, if the normal base cases, if the node is null, simply return, because it's a void function, so simply return. But if the node value is equal to your value P, which is your start node, so LCA to start, put the path string and assign it to LCA to start. While if the node value is equal to Q, which is the end node, then LCA to end, assign the path string, which is LCA to end. Now after this DFS call, my LCA to start, where is it on? Yeah, my LCA to start and my LCA to end, both these strings are populated. Now what I can do, I can simply go and modify entire LCA to start to become a U, right? Again, this is being modified on address, so it is modified to entire U, LCA to start, because I know from P to LCA it is all up, but from the LCA to end it is whatsoever I achieved. So I'll just simply concatenate the string and this is my answer. As I did a simple one DFS call here, so O of n time here, another DFS call here with no copies, no extra time, so O of n time here. Thus total complexity will be O of n plus n, which is O of n for me. Because of using DFS in both the scenarios, which means recursion in both the scenarios, it is O of n space and it is O of n space also. So again, space will be O of n. Now, there is one more approach. If you could have seen it a bit more carefully, if as I was telling you, when you were making your path string starting from the root node, you must have seen it is L, it is L, it is R, it is R, it is L. So the string generated from root, again, I'm not saying from LCA, from root node to this node was L, L and R. Here it was L, R and L. What it means, this specific R means this R. this L means this L, this L means this L, right? The same way, this L means this L, this R means this R, this L means this L. Oh, so this L was common. Then after that, it got diverged. So what you have to do? You have to just get rid of this L. That's what you want to do, so as to get to your LCA. So ultimately I realized that even if I would have generated my path strings starting from my root node, I would have achieved the strings like this. Now the common portion between both the strings for P and for Q, the common portion would have, like, it would have represented as the root to LCA. It would have represented, again, this common portion would have represented root to LCA path. Thus, I don't want it, so I will simply remove it. I will simply remove it. And voila, now you have achieved, again, you have achieved the left string, you have achieved the right, as in like the P string or Q string, modified this to entirely U, get it to entirely R, and thus you are good. So what you realized in this scenario, you did not find the actual LCA. You just get these strings, get these path strings from like to node Q, to node P, to node Q, and then you saw what is common. That common is portion from root to LCA, and then you just simply remove that common part, and then now you have actually achieved from P to LCA to Q. This is from P to LCA, and this is from LCA to Q, and you are good to go. Cool. So the only changes I have removed now, as you can see, I have now removed this entire LCA. I have just simply called my DFS function starting from my root node. So if you go and see, I have called my this DFS function starting from my root node. This is the only change. Exact same code, exact same code, exact same DFS code. Now the only change is this LCA to start is not LCA to start, but from root to start. This is not LCA to end, this is actually from root to end. But I have kept the same variables so as to use the same common code. Now coming on back, I have to go and check the common string. So I will use a simple two-pointer technique, like a simple technique which we use. Let's say it is, let's take the same thing. It was LLR. It was LRL. So I will keep my I pointer here. I will keep my J pointer here. And again, make sure this could have been small. So I will try to compare both, and I will see what is the common length so far. So I will move my both the pointers while I is less than LCA, like this is the length which is LCA to start length, and this is the length which is LCA to end length. I will iterate both I and J. As they are common, as they are same, I will keep on increasing the common length. And again, as you can see, if they are same, I will keep on increasing my common length, and I will move my I and J pointer. I'll move my I and J pointer, and I'll increase and say the common length has been increased by 1. So far the common length is 1. Let's say common length is 1. And again, increase your both I and J pointers. If it is not same, then break. Because I just want to remove the same portion. Now, when I say remove the same portion, I want to make sure the new LCA to start string is LR, which means you can simply say starting from this index I up till the very end. And same way, you can say for your LCA to end string as starting from the index J up till the very end, right? Or in this case, again, there are multiple ways to solve it. I have said that this index I and J, both will be same. It will be equal to common length. Common length is 1. Index will be 1 here, right? Here the index is 0, length is 1. Here the length index is 1, length is 2. But if I'm saying this is the common length which is 1, so right now you are at the index 1 itself. So I went and said starting from the common length, again this is saying common index. So if you don't know substring, the first parameter is actually your index from which you have to start. So this is the index and this is the length of the string which you have to take. So here I told my function that common length is the actual index, start index, and the remaining length you have to take. Same way for LC to end string, common length is actually representing the index from where I have to start, and this is the remaining length which I have to take. And thus I have got my final LCA to start and final LCA to end string which I wanted. And now the same thing modify the entire LCA to start string as you, and then attach both of them and return that to your answer. Same complexity, everything exactly same. It's just that now you don't have to find the actual LCA. I hope you guys got it. If yes, then do smash that like button and please do join on Discord and LinkedIn. Bye bye. Take care. And Twitter also. That's gonna be wild now.